Okay, so I'm going to show you the complete Windows Azure in one picture. Now Windows Azure, it is a platform, as I told you, for running Windows application and for storing the data in cloud. And it runs on machines that are in Microsoft data centers. So it is not a software that you can install on your system, but rather it is a service that you can use in order to run your applications and to store the data in internet. Or you can say store the data on internet accessible machines that are owned by Microsoft. Now Windows Azure, it provides services to businesses, to consumers, and to both. Now what kind of applications you can develop or build using Windows Azure? The one, as an independent software vendor, you can create application that targets business users. So as I told you, if you are targeting business users, the concept we usually call it as software as services, because you are actually providing them the framework for building their own applications with little bit of customization. Now because you are targeting business users, so the concept of scalability as well as high availability both comes in picture here. The second is as an ISV, we can also create SaaS application to target consumers. Now when I use this word consumers, it means we are talking about a large consumer market. Okay. Now when there is a large consumer market that we are going to target, that means high availability and scalability both comes into the picture again. Okay, because you want, maybe some customers might be accessing the application in a particular hour of the day, so you might expect more traffic to your site, right? So that time also you need scalability, and you cannot afford that your application server go down anytime, so that also you want to maintain. So this for targeting consumers, definitely scalability and high availability both comes into the picture. Now for enterprises, again, definitely you can use Windows Azure to build the application for enterprises. Definitely here scalability may not be that requirement here, because you know like what would be the limit and how many employees are working in your organization, but high availability could be one factor, because they might have headquarters or their offices in different locations, and might be their employees work in different time zones, under different time zones. So high availability could be one requirement here. Now Windows Azure has three main components, as I told you. One is compute service, second is storage service, and third is fabric. Now compute service, it runs applications. Storage service simply stores the data. There is third component, okay, which I told you, like I will take up later in the session. It is Windows Azure Fabric, not App Fabric, it is Fabric only. Okay, what it provides, it provides a way to manage and monitor the applications that use the cloud platform, because it is very important. Somebody should be there to monitor and managing your services, because somebody should take up this responsibility that once you deploy your app on cloud, it should be monitored all the time, because we cannot afford that, because the SLA we are providing in Microsoft is 99.9%. So what we are promising to our consumers, that your application will have this SLA. So definitely we cannot afford anytime any of the VM go down like this. Okay. Now the another important thing that I want to discuss here is I'm talking about compute service right now. Okay. Now Windows Azure Compute Service, it can run many different kinds of applications. Okay. Now the primary goal of this platform is to support applications that have very large number of simultaneous users. Okay. Now I'm not using large number of consumers. I have used a very important terms, a very large number of simultaneous users. And if you have large number of simultaneous users, it can definitely affect the performance of your app or site. So that is why we encourage if you're facing this kind of issue, we can suggest as a consultant to our customer to take their app in cloud. Okay, because there this kind of scenario can be handled or managed easily. Now there are two approaches for this. One is a scale up and second is a scale out. A scale up means you're making your machines bigger and bigger. Okay, let's say you have one server whose configuration is ABC, which can handle 500 simultaneous users request conveniently, easily. Now, let's say in another 4 or 5 months, because of lots of promotion and advertisement, you're expecting more users to visit your site, and this number goes up to 1,000 users simultaneous. Now, you want to make your system or server more bigger, stronger. So you can do that. You simply increased its configuration. You take it up to that level. You make it more stronger, and it can handle that request of 1,000 users simultaneously. Now, let's say again after 4 or 5 months you are expecting more users to your site. So like this, there is always a limitation for your server to become more powerful and stronger. So this approach is a scale-up approach, but Microsoft Windows Azure, it is designed to support applications that scale out. Okay, so that means it actually works on the approach of scale out. Now, scale out means running multiple copies of the same code base across many commodity servers. Okay, you have one application, you have multiple copies of your application, but when your applications are executing, you call them as instances. Okay, so you have one code base, but when it is running, you call it as instance. Now here, in this particular approach, each instance will run inside one VM. Each instance will run inside one VM. If you say for high availability, you need to configure at least 2 to 3 servers, because anytime if one server goes down, there should be one backup server. Okay. Now again, let's say you want to maintain the high availability for your site or app, and for that you need 3 instances for your app. Okay. Now when you say I want 3 instances, that means you are requesting 3 VMs from Microsoft Data Center. So when this request goes to Microsoft Data Center, it actually provides you 3 VMs. Okay, it is not like 3 instances running in a single VM. One instance, one VM. One instance, one VM. Now, so Windows Azure application can have multiple instances and each executing in its own virtual machine. And these VMs, they run 64-bit Windows Server 2008 R2 or whichever is the latest Windows Server edition. So let's say today it is Windows Server 2012, so it would be Windows Server 2012. And they are provided by hypervisor. Okay, which is a hypervisor. It is nothing, it is they are based on Hyper-V. Okay, that means they are modified for use in Microsoft's cloud. Now, in order to run your application, you need the subscription. So that subscription will be based on your Hotmail or Live ID. Once you have that subscription, as I showed you just now, like you can also subscribe for a free trial version for 3 months. So it will provide you the access for management portal for 3 months. You can deploy your application there or host your application there for 3 months. Now, during the deployment, you actually provide a package that you want to deploy in cloud plus a configuration file, which is nothing which is simply a XML based configuration file. So there you actually mentioned you want 3 instances of your application. The moment that configuration file reaches to Microsoft Data Center, it provides you 3 VMs. Now, it is very important for you to know that developers, they cannot support or provide their own VM image for Windows Azure to run. There is a good reason, because we do not want this headache to be given to developer. It is to be handled by the Microsoft Data Center itself. So if you're working with PaaS, you can only, because the whole infrastructure is abstracted from you, you cannot provide your own image. Now, if you want like your existing application whichever kind of application it is, if you want to run as it is without any modification on cloud, you can use IaaS for that purpose. Okay, infrastructure as services. So if you do not want any kind of modification, you do not want any investment in code customization, you can go for infrastructure as services. You can take the servers, you can create your own image as wherever you, whichever kind of image you want to create. You can perform customized installation of operating system which is required for your application to run, and then you can run your application there. But in case if you want, like I do not want to manage the infrastructure in that kind of scenario, you need to go with PaaS. Definitely you will get much more less cost for it. Now again, one thing I want to highlight here, as I told you, that Windows Azure is based on instances. Okay, you can run multiple instances of your application, and each instance runs is let me show you here. These are the two kind of instances you can create in Windows Azure. One is a web role and the second is worker role. Okay, now web role instance, you can take it as a front end of your application. Okay, it can interact with the users, it can take the data from them, it can take the requests from user, it can directly interact with the users. So when we design a front end of our application, that means we are allowing the users to interact with the we are allowing the application to interact with the users, because there should be some mechanism by which you can get the data from user, because that is the only way you can run your app. Okay, so web role instance, it can accept incoming HTTP or HTTP requests, and to allow this, it runs in a VM that includes IS 7 or 7.5, whichever is the highest version, because in Microsoft data centers they always use the latest version for everything. So you will notice that it runs in a it runs IS. Okay, let me show you here. There must, yeah, this slide. Now there are two VMs. One VM is for web role and second VM is running worker role. So these are the instances, and as I told you, each instance run in its own VM. Now web role instance, you can see here, it runs in a VM that includes IS, and developers, they can create web role instances using ASP.NET, WCF, or any other .NET technology that works with IS. And if you remember, I just told you that you can also create applications in native code where .NET framework is not required. That means using PHP or Java. Now there is one more thing you can see on this slide. Windows Azure, it provides built-in hardware load balancing to spread requests across web role instances that are part of the same application. It is important, you know, you have 3 instances running, and maybe one who will manage, like it can happen like all the requests are passing to only one instance. So who will manage that the requests should be equally distributed across the running instances? So for this we have this built-in hardware load balancing to spread the requests across these web role instances. Now, by running the multiple instances of an application, Windows Azure helps the application to scale. This is one way to, because when we say it based on its scale out, so we want like all the requests should go to the multiple instances. Now, there is one point. To accomplish this, your web role, it must be stateless. Okay, why you cannot store the client information there in an instance? The reason is Windows Azure load balancer doesn't allow creating any affinity with particular web role instance. Okay, so there is no guarantee that the request which is coming from one user, it will be sent to the same instance. So maybe this user 1, if his first request has gone to the instance 1, the second request may go to the instance 2. So there is no use of keeping the data or making it stateful. So it is the web role instances, they must be stateless. If it is your requirement to keep the client information, you can store it in SQL Azure or in any Windows Azure storage service, or you can process it back to client. Coming to worker role instance, okay, let me take you back to this slide so that you can also view some of the content here. Worker role instances, they are not similar to web roles. Okay, they cannot accept requests from outside world. They cannot interact directly with the users. Their VM also don't run IES. Okay, I will take you back to that slide later. But their VM, they don't run IES. And a worker application cannot accept any incoming network connections. So now the question could be then how worker role actually works. It initiates its own request for input. How? Usually you have web role or worker role in your application. So web role will write some data in a queue. There is a concept of a queue, and worker role will read the data from queue. Okay, so this way it actually initiates its own request. So, and it is also a way like web role and worker role communicate with each other. And you can compare your worker role instance with a batch job or a Windows service, a service that runs in a background. Okay, so you just need to, if you want some kind of a service like this which simply used for processing purpose, you can run it in a background. And how it gets the data? It actually fetches the data from queue and then process it. Let me take you back to this slide, and you can see here this is a worker role instance. Okay, and you can see it. Okay, it doesn't running the IES, so there is no IES inside this VM. Now developer can use only web role instance, or it can use only worker role instance, or combination of both. And if applications load increases, he can use the Windows Azure portal to request more web role instances or more worker role instances, or both. If the load decreases, he can reduce the number of running instances, or to shut down the application completely, developer can shut down all of the application's web role and worker role instances. Now VMs, you can see here on this slide, that run both web role and worker role instances, they also run a Windows Azure agent. Okay, you can see the agent here in both the VMs. Okay, what is the role of this agent? This agent exposes a relatively simple API that allows an instance to interact with the Windows Azure Fabric. Okay, Windows Azure Fabric, as I told you, it is the third component of Windows Azure. Okay, apart from compute and storage services, the role of Windows Azure Fabric is to manage and monitor the running services, because there should be something that will ensure that your service will be available all the time. So this managing and monitoring part will be handled by Windows Azure Fabric, and these agents, they actually provide that information or alert messages or notifications to Windows Azure Fabric about their health, so that your Windows Azure Fabric can monitor them conveniently.